The first demonstration we're going to look at today is probably the feature you're going to be using the ProSim 8 the most for, and that is to either verify or to calibrate your NIBP function of your patient monitor. Sorry, let me just quiet this one because he wants to be part of our discussion here today. Now, firstly, this is our ProSim 8. You will see that on the front here we have the NIBP connector where we're going to connect. With the unit, you get a whole set of tubes and connectors, pretty much like these ones, with which you can make up your own set depending on the brand of patient monitor you use to fit those particular cables. These ones are now obviously set up for the Philips monitor. So the one end goes into the simulator. Sorry, my cable dropped down here. The other end goes to your NIBP cable, and then this end here goes to my NIBP cuff. Now, what is very important is when the cuff which we're going to use, make sure that it's a new and a good quality cuff. And with your simulator, you get what we call a mandrel set. Now, inside this mandrel set is a whole lot of different sizes of mandrels. You can see there all the different ones. So you need to select the correct mandrel for your cuff size. Now, the way we do that, let me just move this one side for us. When we look at a blood pressure cuff, you'll notice that we have two white lines here, and on this side we have an index line. So whenever I put it around an arm or a mandrel, the index line has to be somewhere between these two lines to make sure that it's the correct size of cuff. Otherwise, that is going to influence your readings at the end of the day. So the cuff of the mandrel I've selected, you can see the index line goes between those two lines. So I make sure that I've got the correct size of mandrel and the correct size of cuff. Okay, that then connects up to the other side of the tube. And then we basically set up. This is our on-off button. When we press that, you can hear all the internals calibrating themselves, setting themselves up. Now, one thing I just need to say is when it comes to the way of testing NIBP, it's going to differ from brand to brand. Because in some brands like Philips, I have to apply the pressure to the monitor for calibration. In other brands, if I'm correct, I think the GE products, the patient monitor supplies the pressure to the simulator. So not every monitor works in the same way. Okay, so the method we're going to use is we're going to supply the pressure to the patient monitor. Okay. When we go down to our simulator, when it's switched on, it comes into the home screen, as you can see here, where we've got a normal patient setup with its ECG, respiration, temperature, IBP, and NIBPs. But the test we want to do is we want to send a static pressure to our monitor. So in order to get to that, we have a NIBP function. You can see this NIBP button here. If you press that, you'll see that at the bottom here, you function 1, it says test. If I go to test, I've got 4 tests that comes up here. The first one is a leak test. Now, what we do during a leak test is we are pressurizing the whole system from the cuff to the inside of the patient monitor and everything in between. And then we close the valves and we measure over a period of 60 seconds, 120 seconds, depending on your service manual, what the pressure loss in the system is. That will give us an idea whether the integrity of the whole circuit is in good order. Okay. The second one is our pressure relief test. Now, what the pressure relief test is, what a patient monitor does is it has a first stop in pressure. So when I press the start button, in normally an adult mode, it will probably go up to about 140 or 160 millimeters of mercury. Then stop, then wait to see if it measures a pulse. If not, it will continue to a higher pressure. And so it will keep on increasing until it finds a point where it blocks the pulse of the patient. Now, in order to safeguard the patient, these monitors has an overpressure point, normally around about anything from 280 to about 350 millimeters of mercury, where the monitor will say, up to here, no more, open the valve, release the pressure. Now, with a pressure relief test, that is what we test, to see if that functionality is actually working or not. Okay. The next one we have is the pressure source. If I go into the pressure source, this is just, I am using my machine to apply a pressure, a static pressure. So I'm telling the pump inside of my ProSim 8, please pump up to 300 millimeters of mercury. And the pump will start, it will pump up, it will send the pressure here, and I can verify on my monitor whether the two pressures correlate with each other. Okay. And then lastly, I can use the ProSim 8 just as a manometer. As I said in the beginning, some machines I need to apply a pressure to the machine. Other monitors, the monitor will apply the pressure to the simulator. So in that case where the monitor applies the pressure to the simulator, I switch it to the manometer. And the manometer will give me the reading and I correlate between the two of them. Okay. Now, as an example, let's go back to the leak test. I just want to show you. When I do the leak test, I press the enter button. Then it asks me for a target pressure. In my case on the monitor, you can see I've got 200 set as a target pressure. So by using the up and down arrows here, I can decrease that target pressure to 200. Then I press enter, and then I've got a second button here, function 2, which says test duration. So I'm going to pressurize the system, and then I want to close the system for a certain period of time, and then measure what the pressure drop during that time was. So in my case, or in the case of the Philips monitor, we make use of a 1 minute duration. I say enter, and then on the monitor, on the machine, I press the start button. Now you can hear and you can see how the machine is applying the pressure to my monitor. I can see on my monitor here where the pressure is. Then there's a stabilizing time in which the machine waits for the pressure to stabilize. So you know everything sets out, all the tubes expand, all the valves got it closed properly. He's still stabilizing. You can see our pressures are very close, 201, 201. And then you can see the counter starts counting. So now the pump has stopped and we've closed the valves. And we're looking at the pressure drop over a 1 minute period. In general, I think in the case of Philips, we allow a 6 millimeters of mercury drop over that 1 minute period. If it's more than that, then obviously our solenoids are not closing properly anymore, or the tubes have expanded too much. We need to replace some tubes. Looking at our cuffs, our pipes, you know, all those, everything down the line, we've got to inspect that. And let's see, we're almost there. And there you can see now, I've picked up a leak rate of 3.8 millimeters of mercury over a 1 minute period, which is totally fine. Okay, then let's go back. The next test I want to do is a pressure relief test. Go there, press enter. Then your service manual will tell you what the target pressure is for your monitor. In our case, we normally set it to about 350. Say enter. I press start. The unit starts inflating, pushing my pressure up. And you can see, you heard the ping on the monitor, NIBP overpressure. And you can see my relief valve tipped at 318.9. So then you look at your service manual and see if that's within your specifications. Okay, let's go pressure source, enter. Pressure source is the same as the leak test we did earlier on, just with the difference of it does not have a counter. So I'm just want to correlate the static pressure. So I'm going to say I want the static pressure of, let's say 180. Enter, and I say start. The pump pumps up to 180, and I just correlate the two pressures with each other to see whether the machine needs calibration or not. So it's just a pressure source. Okay, I'm just going to stop here. And then lastly, the manometer, enter. Again, here you see now I haven't relieved the pressure yet, so you can see the pressure in the system. This is now just a manometer. In the case of a Dynamap, for instance, you will do the pressure test from here, and the monitor will supply the pressure towards the simulator, and then you can read what the simulator gives you.